2020 probability question 5. Independent events is what this question is dealing with in second part. And conditional probability in part 1. So if you know your conditional probability, which if you're going to sit the leaving cert higher level and you don't, well then you need your head examined. B, intersection A will go on top for the probability of B given A, and on the bottom the probability of the second one. So the probability of B intersecting with A, given that A has happened, give your answer in its simplest form. So we have the intersection here. We have a half divided by 3/4. The information is given to us. So that's a half. Turn the fraction upside down and multiply. So we're going to get 4/6 or 2/3. Nice easy intro into the exam that never happened for those of you that did sit it. Part 2. A union B. Investigate if they're independent. So the probability of A by the probability of B is equal to the probability of A intersection B to show that they're independent. Now there is other ways to do it using the conditional probability, but I'm going to do it this way. So let's complete the Venn diagram here because we're given some other information. We have A and B. A union B is 11/12 from part 2 here. So let's go back and have a look. We have the intersection was a half and A was 3/4. So the intersection was a half, A was 3/4. Well, we've 2/4 in the middle, so we have to have another 1/4 there. 1/4 and 2/4 is 3/4. A union B is 11/12. So I have 3/4 in there already. And just be careful you don't make a mistake with basic stuff. 3/4 is 9/12. So that's what's there already. So I have to have 2/12 here. So we have 2/12, we have 6/12, and we have 3/12. 2, 6, and 3 is the 11 that are mentioned above. Just double check all your workings. So are they independent? Let's check. So A, 3/4. Multiply the probability of B. Well, we have 8/12 if you want to take the 6 and the 2, and 8/12. I'll write it as 8/12 for now. That's A. That's B. So what's that equal to? 24/48, which is 1/2, which is equal to the probability of A intersection B. Therefore, we can say that these events are independent. Nice easy question when you know this really simple rule that you've taken the time to learn. Okay, spinner question. I think maybe a little bit unfair, this question, the way it was phrased. But if we just do if we see expected value, we know we have to do expected value. We could do that first. Although in this case, we're going to read the question. There's a little kind of trick with our little hidden thing inside this question, maybe that I missed the first time I read it. A spinner consists of 4 segments. Each segment is equally likely. Liam, Sorka, and Lee play the game in which the spinner is spun twice and the numbers landed on are added together. So it's a bit like the 2 dice question. Then the result is divided by 3 and the remainder is recorded. So it's the remainder that's important here. It's a funny question that they've made up here. Right, so let's do our two-way table. We have spinner 1, 1, 1, 2, 3, and then the second time 1, 1, 2, 3. So I think a two-way table is probably the best way to see what's happening here. You could just write out the probabilities or the combinations of what's happening, but I think this does it quicker. So let's just change to red and fill them in. So 1 and 1 is 2, 1 and 1 is 2, 3, 4, and it's the same again here. 2, 2, 3, 4, 2 and 1 is 3, 2 and 1 is 3, 4, 5, 3 and 1 is 4, 3 and 1 is 4, 5 and 6. So these are all my outcomes. So I've 4 by 4 outcomes. Now, do we need to do the probability? If the remainder is 0, then Liam wins the game. If the remainder is 1, then Sorka wins the game. And if the remainder is 2, so we just need to look at the remainders. So then why don't we do up a two-way table with remainders as well? Do it here. So I've got my, just need the inside of my table actually here. So the remainders in red, I'll do the 0 remainder. So like this one here has a 0 remainder. The 3s, they're the most obvious ones to start with. Just let me change color. Red, 0 remainder, 0 remainder, 1 to the left. So is there 4 3s and 1 to the left? 4 3s. You can see in this case, in green, we'll do if the remainder is 1. So that's when the division is 4, so the remainder is 1, 1, starting here and going this way. We could just circle them, but I'm just going to try and make it a bit more visual for you to see. A 1 and a 1. Now, a 5, what's the remainder for a 5? The remainder for a 5 is a 2, so let's do that in black, the 2s. The remainder for a 5 is a 2. Now, what about this one down here, the 6? What's this one? Well, 6 divided by 3 is 0, so that's another 0. Put my 0 in, and I'm just left with these 4 2s. So what happens if I divide 4? If I divide 2 by 3, 3 doesn't go into 2. 2 divided by 3 is equal to 0. Doesn't go in, but what's the remainder? The remainder is 2. So all of these have a remainder too. So they're going to need to go in black as well. And that's the thing that kind of caught me the first. I was like, is that a remainder too, or can we discount them? But that's the remainder too. So you can see there's 6 2s, there's 5 0s. Just write them down. There's 6 2s, there are 5 0s, and there are 1 2 3 4 5 1s. And you can see 5 and 5 is 10 and 6 is 16. So there's 16 outcomes. One of them happens slightly more than the others. And we're asked, is this a fair game? So we're actually not looking for expected frequency, which is what I did the first time I kind of had a look at this question, went straight into 1 times a quarter and so on. But that's not what they were asking here. So who has the most likely outcome to win the game? The remainder is 2. So actually Lee's going to win this game in the long run very slightly.